Welcome to my channel, Physics Guru. And today we're going to talk about how to calculate the force between two charges. So here we have two charges, Q1 and Q2. The value of charge Q1 is given by this number here, and it's a negative charge. The 2 times 10 to the negative 20 coulomb, and the other charge is 1.8 times 10 to the negative 20 coulomb. So one is negative and the other is positive. And we have to find out the magnitude of the force between these two charges. So let's do that. So here I have written down all the given values here, Q1, Q2, and the distance between these two charges are given. That is 5 times 10 to the negative 9 meter. So in order to find out the force between the two charges, we're going to use the Coulomb's force. So what does the Coulomb force tell you? That the force between the two charges is given by this equation, where K, this K is a constant, and the value of K is 9 times 10 to the 9 Newton meter square per Coulomb square. That's the value of K. And this value is a constant. And this constant is only when the two charges are in the vacuum or in the air. If there's a change in the medium, now let's say, for example, if the two charges are into water, then this value of K would change. But for this class, simply remember this K is a constant quantity, and only thing we have to remember, this value of K is 9 times 10 to the 9. All right, so let's plug in all the numbers here. K is 9 times 10 to the 9 because I already told you this is a constant. Q1 is given, and here we're only interested in calculating the magnitude of the charges. So simply take just the magnitude of Q1. So here's Q1, and I'm just taking the magnitude here. Q2 is 1.8 times 10 to the negative 20. And R is a square, so that's the R value. And that tells you the magnitude of the force between the two charges. So now, if I ask us to calculate you the direction of the force, so the direction of the force can be given or can be calculated this way. So here, this is a negative charge, that's the positive charge. So what kind of force will be between these two? It will be attractive force. So that means this charge Q2 will attract Q1. So the direction must be this way. And exactly the same way, Q1 will also attract Q2, or there is an attractive force between Q1 and Q2, and the direction of the force is this way here. All right. So Q2 attracts Q1 and Q1 attracts Q2. Although the magnitude of the two charges are different, the force of attraction by Q1 on Q2 and by Q2 on Q1 will be exactly the same. Okay,